Okay. Narinig ba ako? Good afternoon, Andre and Rod. No? Thank you for joining us today. Tapos, siguro may habol pa naman. No? Okay. So, let's begin with ano lang muna, no? A short update lang sa course guide natin. So, if you look at our course guide, may konting magbabago pala sa schedule, no? Kasi we've actually just recently released so let me just move. To. So recently lang namin na-release si Entropy, no? So and all of these updates can be or is reflected sa UVLE naman natin. So you can just check it out. Pero ito, this deadline will be moved, no? So if you look at our schedule, let me just look for it now. So ito, Entropy. So Entropy quiz is this one, and it's due on November 18, no? Okay. So we've decided na ito, balik tayo sa course guide. This one will be moved November 18. Tapos itong free energies natin na na quiz, this will be moved on November next week, which is Wednesday, I think. So it will be moved on November 24, just before the the long exam number 2. Okay? So ito November 24 na to. Okay? Siguro I'll just add para mabilis natin ma-check yung yung mga schedule natin. Magdadagdag na lang ako ng new activity dito sa UVLE, which just shows the updated na parang schedules natin. Okay? So today is November 16. So we'll be discussing about free energy, and it's a medyo long yung discussion, no? And we might need to meet on Friday. Pero if we are able to finish it today, then pwede naman hindi na tayo mag-meet on Friday. Or rather, pwede naman siguro na another option is ang gawin natin is we finish what we can today until 5:30. Tapos I'll just continue the recording. Tapos i-discuss ko na lang yung mga other topics to be discussed if in case hindi natin matapos by 5:30. Tas yung mga kailangan umalis pa din mang umalis. Okay? So mas okay siguro yun para at least kumbaga video on demand na lang yung dating for you guys. Alright? Ay, sorry. Hindi nyo pala nakikita yung screen ko. Hindi nyo sinabi. Okay, ito. So let me just repeat what I said. So, nagre-record na ba ako? Yes, I'm recording now. So, again, itong sa entropy quiz, we moved it to November 18 na yung deadline. So, which is this Friday, no? This Thursday, I mean. Tapos, itong free energy quiz will be moved into November 24, which is just before the release of the second long exam, no? Okay? Tapos, again, because of the how long the coverage is, posible na mag-extend tayo ngayon. Pero again, after 5:30 pa rin ang umalis yung iba. Tapos I'll just continue recording and discussing the answers. No? Tapos i-upload ko na lang yung consolidated na video file doon sa natin, recordings na activity. Okay? So, let's go to jump na tayo straight sa examples natin, no? Para we'll cover a lot of ground today. So, diretso tayo sa first problem natin. So, this is our first problem. Meron daw tayong the reduction of your zinc oxide into pure zinc through its reaction with carbon monoxide, no, or CO. Tapos, the reaction goes like this. So, nakikita naman, no? So, the reaction goes like this. So, ito yung main reaction natin. And we have our reductant here is yung CO, no? And yung gases na yung gas evolved because of of this reduction process is your CO2. Okay? So I'll teach you how to use or I'll teach you the calculations involved. Tapos pwede rin tingnan natin yung if we were to use the Ellingham diagram. Oh, but let me double check, no? Kasi baka hindi na kailangan yung Ellingham. Maybe Ellingham, oh sorry. Ellingham is ano pa pala, no? After long exam 2. So siguro hindi ko muna i-cover si how to use Ellingham to solve this uh, types of problem, no? Pero just a preview, you can actually use Ellingham diagrams to solve this type of problems, and it's much easier, no? Kasi graphical yung approach ni Ellingham. And we bank on the parang works that have already been done para mas mapabilis yung calculations natin. Okay? So, let me just prepare. No? So, ito tayo. So, wait lang class ah. Okay? So, we start with this equation muna, no? And we are to get, ang kailangan this is our working equation, no? And the first thing we always do is to check if balance yung equation, no? So, that's the first thing. And if we look at it, we have ZNO plus CO yields ZN plus CO2. Okay? And meron tayong 1 ZN, CO is 1 here, also 1 here, so that's 2. Tapos CC is 1 and 1. So balance naman yung equation, so no need to further balance it. No? Okay? So meron tayong two equations. These are the half reactions or the stepwise na reactions involved for us to achieve this balanced reaction. No? Ang gagawin lang natin is we just add these two reactions. No? So if we add the two reactions, we should get this cancels out. So we should get this equation right here. So let me just write that down now. And siguro so this gives us ZNO solid plus sorry. We need to tama naman pala. So that's CO gas. This is a reversible reaction. No? Again, ito hindi na when we talk about free energies na class, no, yung pag parang mga balance reactions na involving yung yung free energy calculations, we don't now assume na all of the reactants will 100% transform to your products. If you remember yung mga delta H natin na calculations, usually ina-assume natin parati na unless otherwise specified by the problem, no, ina-assume natin parati na 100% yung conversion niya. Pero in this in the real world, hindi naman lahat nagko-convert, no. There will be always be a parang a forward reaction that is occurring, tapos meron ding reverse reaction na nag-occur, no. And once these systems are allowed to take place, actually what ends up happening is the forward reaction now equals the reverse reaction, and parang the system is said to be in equilibrium, no. And in free energy calculations, we can now determine kung ano yung magiging equilibrium na niya, na concentrations for the reactant side and the product side. Okay? So, eto, we have that's Zn and the vapor phase plus your CO2 in the gaseous phase as well. Okay? So, ito yung ano niya. And yung delta G niya will just be the addition of these two values, no? So it still follows Hess's law. So we have, let's double check. Hindi naman siya magre-reverse, no? Kasi we just added it straightforward. So if that's the case, then we should get, and we can use our calculators dito, no? So let me open my calculator. Sa screen nyo, nakikita nyo naman, no, na nakabukas yung calculator ko. So, ayan. Ilagay ko na lang dito si calcu. So this is, namatay yung calcu. So I have 460. Ayaw gumana ng calcu ko. That's 460. 0.2. So I'll just place this in terms of kilojoules, no, para mas madali siya calculate. Minus 282.4. Okay? And that gives me 1778. That's 177.8. Uh, Tapos, and both of these are in terms of, uh, yung equations niya is in terms of, or is a function of temperature. So we have 198 plus negative 198 plus 81. No? So that's 81 minus 198 gives us negative 117, and we divide that by 1,000 kasi we're now dealing with kilojoules. No? So we can do negative 117 0.177 T. Okay. Pwede nga. Okay, so if we, and the question is, ano kasi yung the question that the problem is, or the problem asks us to compute for the partial pressure of the gases at 950 degrees Celsius and what one and at 1 atmosphere. No? So this is saying that ano yung magiging concentration na after it has reached equilibrium. No? Okay? So ito yung sinasabi ko kanina na yung forward reaction and the reverse reaction have reached the same parang rate, no? So meaning wala nang change, overall change na makikita tayo. Although meron pa rin mga kumbaga mga micro changes, no? So one molecule of ZNO could react with one molecule, or um, one mole of ZNO can react with 1 mole of CO to produce 1 mole of ZN and CO2. Parang ganun. Tapos pwede mag-reverse din. But because the rates are now at equilibrium with each other, mangyayari is overall wala na tayong ma-observe na parang macro level na changes in terms of concentration. No? So with that being said, parang pwede natin sabihin na we have reached equilibrium. Okay? So the relevant equation that is needed, and this is delta G naught. No? Okay? So hindi ko na masyadong in-depth i-discuss yung difference between delta G and delta G naught. No? Pero if you read your modules, you should be able to differentiate it by now. And if the topic comes up, pwede ko namang i-expound later. No? Pero I highly advise na you go over your modules, try to read the difference between delta G and delta G naught. And also, nag-release na kami ng podcast, no? And we also touched on it, yung explaining the difference between the two. No? And I think yung mga articles din na pinrovide namin, lalo na yung mga external websites, they also have good explanations for delta G and delta G naught. No? Okay? So this is delta G naught. This is kumbaga the reference na standard free energy. No? Okay? So we have delta G naught, and the equation is yung relationship between delta G and delta G naught is delta G naught is equal to delta G is equal to delta G naught plus RT ln Q, no, or reaction quotient. Now, since we are assuming that this is at equilibrium, and delta G again is para siyang it's an indicator of your spontaneity of system or reaction. And if it's negative, it will proceed in the forward direction. Pag positive naman siya, it will proceed, it will favor the reverse reaction. Tapos pagka zero naman, it is said to be at equilibrium. No? Okay? So in this case, since we are trying to find the delta G at equilibrium, then therefore we can set this to 0, and we have delta G naught is equal to negative RT ln. And if you remember your chemistry, pag ang reaction quotient mo is already, or we are talking about reaction quotients, in equilibrium, we replace it with what we call as the equilibrium constant, no, or yung KEQ. So hopefully you still remember KEQ, no? And just to refresh your memories, usually yung reaction quotients natin is written as yung activities. So in general, it's activities of the products. So if we have something like AA, or sorry, sige, simplify lang natin, no? If you have something like this, A plus B proceeds to C plus D, then we have the activity of A multiplied by the activity of C multiplied by activity of D divided by the activity of A multiplied by the activity of B. So ito yung general na equation for the reaction quotient, no? And it depends on what type of system. Usually pagka sinabi nating AQ system, ang mangyayari is we are dealing in terms of molarity, no? So you will have something like this, yung concentration ng C, concentration ng D, concentration ng A, concentration ng B. So hindi ko na lang nilagyan ng ano, no, ng parang coefficient para hindi tayo malito. Pero usually pag may coefficients tayo, parang ganyan, what we do is we just raise it to the power of its coefficient, no? Or coefficient. Okay, so we have something that looks like that. Okay, now if you look at this particular case, we are dealing with gases, no? And sabi natin is kumbaga hinanap natin yung equilibrium partial pressures, no? So when it is in terms of gases, usually it's yung partial pressures yung kinukuha natin, no? So partial pressure of C multiplied by partial pressure of D raised to D raised to C, ganyan siya. A raised to the power of A and partial pressure of B raised to the power. So ito yung mga standard forms natin, no, for when we compute for the reaction quotient. Okay? And since we are dealing with the equilibrium conditions, then therefore the reaction quotient becomes the equilibrium constant, no, KEQ. Right? So in this particular case, and this is a preview na lang siguro sa other or a review na lang, I should say, no, kasi diniscuss naman to. If you remember your chemistry, whenever you have condensed phases or condensed phases in their stable form, then we have what we call or yung activity natin for that particular species will be just equal to 1, no? So condensed phases are usually the solid tsaka yung liquid phase. So we call that as condensed phases, no? Okay? So if we look at our example, so let me just expand, no? So we have delta G naught is equal to, this is negative, and we are isulat ko na yung ano, no, value. So that's 8.314. This is in terms of kilojoules na to, no? 8.314 kilojoules per mole Kelvin. Ano, sorry, 8.314. Tama nga ba? Naka-joules na ba yun? Gas constant. Let me just double check last now. It's in joules pala, sorry. So this is joules per mole Kelvin, yung 8.314. Okay? So we go back. Okay. So ito, 8.314, tapos T, we are at constant temperature, no, which is 950. So that's 950 plus 273 because again, we always use in thermodynamics, no, always ginagamit natin yung Kelvin. Okay, so that's 950 plus 273. Then we multiply it by L. KEQ is equal to, for this case, no, it's the activity of your the product side natin is activity of CO2, activity of Zn, tapos we have the activity of ZNO and the activity of CO in the gaseous phase. No? Okay? So, dito, if you look at it, CO is, sorry, if you look at this, the ZN phase, ito, this is a pure phase. No? So, the activity of a pure phase is always 1. No? So, this becomes 1. Tapos, the activity of a pure condensed phase, so ito, si ZNO, is just also equal to 1. No? So, pure meaning parang condensed phase siya, solid na, tapos pure ZNO lang yung material na yun. No? So, kasi sometimes, for example, if you have uh, iron, kunwari, pwede kasi siyang may impurities, no? Like, for example, alloyed siya with mga 0.01% carbon. So, magiging steel yun. So, pagka ganyan, yung activity niya hindi na equal to 1, no? So, pero later on, pagka nag-proceed tayo sa, I think, sa third coverage natin, which deals about solid solution, or that deals about solutions in general, no? Ideal and real solutions. We can tackle that, no. Preview lang, Henryan activity yung tawag natin sa ganun. Pero in this particular case, we just assume na ZNO is pure ZNO, no. Okay, so this becomes also 1. So ang matitira lang sa atin is activity of CO2 divided by the activity of CO. And parang fortunately, ang coefficients naman niya is just 1, no? So, all 1 lang dito. So, 1, 1, 1, 1. So, tig 1 mo lang siya. So, raised to the power of 1 lang lahat yan. Okay? So, we have, this is, and compute ko na siguro para pwede ko nang iyan to. So, that's 8.314 multiplied by 950 plus 273. And you can calculate along with me, class, no? Tapos just tell me if mali yung na-calculate ko na value. Okay? So that's 0.0122 ln of this now. Again, ang sinabi ko kanina, pagka we are dealing with gaseous phases, activities are measured as partial pressures. No? So that gives us the partial pressure of CO2 divided by the partial pressure of CO. Okay? So, now that we have this, we can now compute for ano no, itong ratio na to. Okay, so later on after we get the ratio, papakita ko sa inyo kung paano natin ginagamit tong ratio na to para ma-solve yung individual na partial pressures for CO2 and CO. Okay, so we have delta G. Ano ba tayo? I'm sorry. So, meron na tayong delta G not delta G not natin. I think we've already computed this, no? Ito, nandito siya. And siguro we will finish this equation right here. So, we can input the 950 plus 273. And let me just compute that real quick. No? So, that's 950 plus 273 is equal to 1223. So, ito. 1223 Kelvin input natin dito. And delta G now becomes 177.8 minus 0.117 multiplied by 1223. Okay, so that's 34 point, ano to? 34.70, let's just say 71. Sige, hindi tayo magkano round off. 71 kilojoules. No? Okay, so pwede nating i-equate yung dalawang to, no? Kasi we already computed for this one. So, pwede nating ilagay siya dito. So, that's 34 point. Ay, dapat pala hindi ko kinonvert into kilojoules, no? Kasi naka-joules per mole. Kelvin kasi to eh. Ano, sorry, joules per mole pala to. Okay, so it's fine. We can just multiply that by 1,000. So, it gives us 34,709. Okay. And 34,709. Okay. So if I want to get ln, the ln value, no? So Pwede nyo siyang i-rearrange, no? Pero what you can do is if you have a calculator that looks like this, actually pwede nyo i-input lang straightforward yung equation, no? So to get PCO2, and I'm sure most of you are familiar with how to use the parang shift solve na function dito sa calculator, no? Pero I'll show it as well. So we have 34709 is equal to negative 10168.022 multiplied by ln and let's just call it alpha x. So ito kasi yung hinahanap natin. No? Now, what we do is we just press shift solve. And whenever you do shift solve na equation in your calculator, no, pinapa-input kayo ng guess value. So in some cases, no, importante yung mag-input tayo ng parang reasonable na guess value. No? Pero in this case, since hindi naman natin alam kung ano siya, ang pwede nating gawin is kasi posible kasi na mag-proceed siya sa kung lalo na pag may multiple roots ka, no? So what the guess value entails is that it will approach the root that is closest to the guess value na in-input nyo. Okay? So para siyang cancel ko tuloy. Pero anyway, let me just explain it kasi this might be helpful sa inyo lalo na sa parang other majors nyo, no. So if you the way the calculator does actually iterative pa rin yung calculation niya, no. Pero if you have a function that looks like this kunwari, no. So if you have a function that looks like this, ibig sabihin nito mayroon siyang dalawang roots, tama? So let's just do ganyan, no. So, kunwari lang, diretso pataas na to. Sige. Let's do one with 3 roots, no? So, kunwari ganyan. So, ibig sabihin nito, if this is the x-axis and this is the y-axis, let's do parang ganyan, no? X and y-axis. Ang ibig sabihin kasi nito is that where it touches your x-axis, that is the solution where f of x is equal to 0, no? And that is the solution to the particular function na yun. Okay? So, ibig sabihin nito, meron siyang 3 roots. Now, what the guess value does is, hinahanap niya, for example, meron kang guess value na dito. So, if you input this guess value, the way iteration works is, and siguro pag sa masters matutunan niyo to, no? This is, and baka kahit sa undergrad tinuturo to, pero this is an iterative approach. No? So, parang numerical method to. So, what happens is, it approaches the closest na root. No? So for example, if I input the guess value here, so it will approach the closest root dito. Tapos kung ito yung guess value ko, ito naman yung closest root na i-approach niya. Okay? So this is important because sometimes, kunwari 0 lang ang in-input mo, and let's just say, kasi kunwari dire-diretso lang yung calculation natin. No? If we just input 0, kunwari ganyan, posible na closer yung negative na root. So, hindi ko sinasabi na ganito yung function natin na. Pero just in case na ganito siya, kunwari, posible na if you just input the guess value here, then it will approach the negative root. Now, in this particular case, you will notice na PCO2 and PCO should not have a negative root, no? Kasi wala namang, kumbaga, hindi dapat magkakaroon ka ng negative partial pressure dito. Tama? So, if you are faced with that, and yung pag nag-shift solve tayo, usually tinitake into account natin yun. So, let me, kung na-retain ba? Hindi niya na-retain. Ulitin ko na lang. Input natin ulit lahat. So, that's 34709 is equal to negative 10168.022 multiplied by ln of alpha x. Okay? So, shift solve. Tapos, ang gagawin natin is, para ma-ensure natin na positive value yung makuha natin, let's just input a random na positive number. No? So, I could just do 0.5 siguro. Para ganyan. Now, if I do shift solve, I should get itong 0.03. Okay, so that will be now my PCO2, 0.03. 0.33. Okay. Let me just double check last now. Bakit kaya iba yung nakukuha sa handouts natin? Double check ko lang, ah. And please double check with me as well, class. Para record lang natin. 8.314 times 1223 gives us 10168.02. Tama naman. Tapos, is this negative? Positive naman to, no? Tama? Hmm, not quite sure. Sige, let's just continue on. Pero wait lang. I-double check ko nga to. So if we have alam ko na. Sa notes, it's 111.19. Bakit kaya 111.19? 198. Yun dito na part, no? Parang naging 111.19 yung sinolve niya. Pero it's negative 198 plus 81 gives me 117 naman siya. So, yun. Doon siguro nagkamali. Okay? Okay, so i-ano na lang natin yun. Okay lang yan. Okay? So, we have this equation of though. So, we have 0.033. So, that is the ratio. And we also have the condition na sabi daw dito, yung total pressure when this reaction occurs is at 1 atmosphere. No? So kung 1 atmosphere siya, that is saying na that and this is from what we call as Dalton's law. No? So the total na atmospheric pressure is equal to uh, is proportional to the concentration of the partial pressures. No? So parang ito, the P total is equal to PCO2 plus PCO. Okay, so in this particular case, we have one equation, we have two equations. We have the first equation here, second equation. That's two equations, and we have two unknowns, which is PCO and PCO, PCO2 and PCO. Then therefore, kaya natin i-solve to, no? And let me just replace this P total with 1. Kasi sabi naman, 1 atmosphere daw yung total atmospheric pressure, no? So, with that, kaya natin i-solve to, no? And we can use MS Math or pwede ring i-solve lang. Sige, pwede natin i-solve lang directly. No? So we can just input PCO2. So if tinatamad kayo, pwede namang mag-system of equations kayo. I-input nyo na lang sa uh, thank you, John, pala, for the feedback. No? 0.033 din nakuha ni John. Okay? So, if tinatamad kayo, pwede naman mag-system of linear equation kayo. Pero for this case, gawin na natin, diretso na natin. So, pwede na rin PCO2 is equal to 0.033 PCO. Yung gawin natin. So, with that, pasok lang natin dito. So, we have 1 is equal to PCO2 is equal to 0.033 PCO. PCO. So, that gives us 1.033 PCO is equal to 1, and therefore PCO is equal to 1 over 1.033 over 1.033 gives us 0.96968, okay, atmospheres. So that is the partial pressure. Tapos, If you compute for PCO2, that gives us 1 minus this value. No? So let me just do minus 1 gives me 0.03, round up na ako, no? 0.32. So this should be my final answer. Ito. Okay. So questions. Okay tayo dito sa first problem natin. Hopefully same tayo na nakuha class, no?
Sir po. Sir, matanong lang po ulit ako, sir.
Go, Mark.
Hindi ko po maintindihan. Paano po tayo nag-come up ng ano, sir? Tawag nito, tawag nito, hindi ko lang masyadong maintindihan, sir, ako. Di ba pagka yung ln, KEQ, di ba ln Q, then naging ln KEQ, and then naging, tawag yan A
Ito.
sub Zn, like that. I don't know how you're going to address that technical term. And then, naging PCO2. Hindi ko lang po mag-guess kung bakit po nag-push out ng ito. Zn at saka ZNO po. Bakit naging 1 na lang siya? Kasi kanina na-explain nyo na po. Di ko lang
Okay.
talaga di ko
Kasi parang ano kasi siya eh. When you have a general rule kasi to, Mark, no? Kasi pagka meron kang pure phases, yung activity niya is always equal to 1. So in this particular case, yung pure phase na zinc, it has an activity always equal to 1, no? And if it is the stable form at that particular temperature, and at 950 degrees Celsius kasi yun yung stable form ni zinc, no? The gaseous zinc. Okay, so kaya siya 1. So for example, if you have another reaction, no? And tapos meron kang activity of zinc and this is now at 298, tapos naka-solid to, its activity will also be now equal to 1. Pero kung if we talk about kunwari activity of zinc na vapor in its vapor phase, tapos nasa 298 tayo, yung activity nito will not now be equal to 1, no? So kailangan natin i-take into account yun kung anong temperature. Pero in this particular case, yun yung dahilan kung bakit si zinc naka-activity equal to 1 siya. Now for ZNO naman, its activity is equal to 1 because it is a pure condensed phase. So any substance that is in the condensed phase and it is pure, no, meaning wala siyang halong impurities, then therefore its activity will always be equal to 1. So for example, if baliktarin natin, no, or let's take another example, no? For example, you have something like ano ba magandang example? In water, no? So for example, if you have um, Zn, let's just say Zn plus H2O, no? Yields, oh no. Ay, ito na lang. OH or H2 plus O2 yields H2O, no? And this is, let's just say na aqueous to. So in this particular case, yung activity ni water, if this is the liquid phase, will be equal to just 1, no? So yung denominator nyo will be equal to 1. Tapos O2, ito hindi kasi siya yung pure, ano ba tawag doon? Yung activity ni O2 will be the partial pressure of O2 in this particular case. Tapos partial pressure ng H2 naman. So whenever it's yung kung nag-exist siya as a pure metal or a pure element in its elemental form, always activity is equal to 1. Tapos pagka naka-condensed phase naman siya and it's a pure substance, in that condensed phase also activity is equal to 1. Okay, so it has something to do with yung ano niya, no? Parang kung ano yung neighboring atoms niya, kumbaga. So kung pure substance ka kasi, yung neighbor atoms mo is just the same. Kumbaga, kunwari, yung ZNO, yung neighboring niya is also ZNO. So kaya wala siyang activity relative to the system, no? Kaya one lang siya or unity lang yung activity niya. So, meron siyang meron siyang theoretical basis pero hindi na siya covered sa lesson na to, no? In this particular part kasi we this is already assuming na you learned this from your chemistry lessons, no? So, yun lang siguro kailangan yung tandaan. Pagka pure element, kung number one, pag elemental, naka-elemental um, elemental form siya, meaning elemental form is etong zinc. No? So, kunwari, kung O, that's the elemental form. H is the elemental form. Zinc, that's an elemental form. And for example, if you have Fe, elemental form yan. So, if it's in its elemental form, stable elemental form at that temperature, then its activity is equal to 1. So that's the first rule. Tapos yung second rule, if it's a pure condensed phase meaning liquids, solids, then its activity is also equal to 1. Okay? So kaya siya activity equal to 1 dito for both cases. So ang matitira na lang dito is just activity of CO2 and activity of CO. Now, yung activities kasi it can be measured in different ways, no? And it all depends on the system. But if you have gaseous system, activities are measured in partial pressures. So kaya siya na-convert into PCO and PCO2 over PCO. Now,
Okay
for
po.
example, if you have something that looks like this, and sige, baguhin ko to, no? So let's do H plus OH minus yields H2O. This is parang a aqueous phase, no? Ito mga ions, no? So these are in its ionic phase. So ang mangyayari diyan is yung and since nasa aqueous solution to, this is now measured in instead of measuring it in partial pressures, activities are measured in your molarity, no? So pag lalo na pagka ano siya, small amounts or dilute amounts. Kung dilute amounts is measured in molarity. Okay? So, okay ba yun, Mark?
Opo, salamat sir. Okay na po. Thank you po.
Pero siguro we'll have more examples on this lalo na pag nag-solutions na tayo, no? Kasi yung solutions mas ma-discuss natin to different na itong mga activities na to, no? Pero right now, kailangan nyo lang matandaan yung two rules na yun. If it's an elemental form in its stable elemental form for that particular temperature range, then activity equals to 1. Tapos pagka pure condensed phase, its activity is also equal to 1. Okay? So, yun. So that's problem 1. And hopefully nasundan niyo naman lahat, no? Let's go to problem 2 naman. Okay? And pwede siguro i-extend ko na lang to. Let's extend this downwards para okay. Let's go to another problem. And yung next problem natin. Wait lang ha. We have sample problem number 3 naman tayo. So sample problem number 3. Let me just take this out. Oops. Okay. Okay, so we are to consider a equilibrium reaction, no? That's SO2 plus 1/2 O2 yielding SO3, and all of them are in the gaseous phase. Now, the standard Gibbs free energy change for this reaction is delta G naught is equal to negative 94,600 plus 89.37 joules. It is 89.37 times temperature T, and that is in joules. Now we are to calculate the equilibrium partial pressures of all the gases at 1000 Kelvin. So the steps here are the same, no? And I think we can, sorry. Medyo magkaiba pala. Okay, so let's try to solve this. So to understand this problem, kailangan natin i-set up yung tinatawag na ice table, no? So hopefully you still remember from Chem 16 kung ano yung ibig sabihin ng ice table, no? Okay, so we set up ice table. So let me just start. So we have what we call as the ice table, no? Okay, so we start with the reaction, no? And the reaction is SO2 gas plus 1/2 O2 also in the gaseous phase yields SO3 in the gaseous phase na ganyan, no? Now, we know that we are starting, although hindi kasi masyadong binanggit sa problem, no? Pero in this particular is different from this first problem, no? Kasi doon sa first problem, we are assuming that that it is in equilibrium na, no? So we just want to know kung ano yung partial pressures na at equilibrium when we have this species involved, no? Okay, and the difference between that one and this one, in this particular na reaction na to, we are starting with the reactants, no? So meron tayong um, parang the 1 mole of SO2 and 1/2 mole of O2, and we have 0 moles of SO3. Okay, so yun yung main difference, no? So meaning that the reaction has not occurred yet. Now the problem here is asking kung after this reaction has occurred, itong SO2 plus 1, the reactants forming this SO3, ano yung magiging partial pressures when it now achieves equilibrium. Okay? So to set that up, we need the ice table, no? So the ice table, this is taught in chem, no? Yung sa college chemistry. Basically, what you begin with is you begin with I here stands for initial, C is change, tapos E is equilibrium. Okay? So if we start with 1 mole, tama? 1 mole of SO2, tapos for every and this is based on a per mole of the reaction, no? So if this is 1 mole of the reaction, meron kang stoichiometric ratio kasi uh, pertaining to each mole of the reaction. So for example, ito, 1 mole of the reaction entails that you have 1 mole of SO2. Tapos for every mole of this reaction, you have 1/2 mole of O2 naman. Tama? Tapos dito, again, this is your initial. You start off with 0 moles of SO3 kasi hindi pa naman siya nagre-react. Okay? Now, once you, the change here now is merong X amount of X amount of the reactants that will react to form SO3. So again, ito yung sinasabi ko kanina na um, dati doon sa for simplicity sake, no, nung sa delta H reactions, and usually kasi it's very spontaneous kasi tong mga process na to, no, that usually it produces 100% na conversion, no, pero technically parang ang nangyayari lang diyan is parang if you compute for the KEQ, it is very very large number, no, so very large number siya. So kaya siya parang it's as if 100% of the products have reacted to form, or 100% of the reactants have reacted to form the products, parang ganon. Pero yun yung assumption sa yung previous topic natin, no, so when we talk about delta H. Pero in this particular case, we are assuming na hindi, or in these types of reactions, hindi natin ma-assume na itong KEQ is very much greater than 1 to the point that it seems as if 100% conversion tayo ng reactants to products. So only a small part, or hindi naman small, pero only a fraction of the reactants will actually form the products, no? And at equilibrium, you will get the parang ratio between the products and the reactants, and that is computed through KEQ, no? So yun yung magiging parang final na ratio niya. So KEQ is essentially saying na if you have if you have established your equilibrium, dapat you will expect this amount of SO2, this amount of SO3, I mean, tapos this amount of this is gaseous, no? So partial pressures to, pero parang this amount of SO3, this amount of SO2, and this amount of O2. Okay? So for example, if dinagdagan ko yung O2 ko, ang mangyayari is this other values will react such that, or these values will change para kumbaga tataas siya or bababa to maintain the established na KEQ. Because for these types of reactions, meron talagang kumbaga equilibrium point kung saan equal na yung rate. So if I could graph it, no, para siyang something like ganito. So if this is products, this is reactants. Sorry, baliktad. This is reactants, and this is products. So what happens is if you have, this is your equilibrium point. Parang ganyan. So this is equilibrium. So if you have too much reactants, parang natural tendency niya is to go in the forward direction para ma-produce yung products. If you have too much products naman, natural tendency is to go down para produce ng reactants. Okay? So parang again, ito yung sinasabi ko kanina na the reactants are always moving forward, no? Moving forward to produce SO3, and the SO3 is also always breaking down to produce or nag-undergo siya ng decomposition reaction to produce its reactants. Always forward and backward, nangyayari parati yun. But what the equilibrium condition is saying is that yung rate of the forward reaction, again, it is just equal to the rate of the backward reaction such that we don't notice any changes anymore. Kasi equal lang yung rates nila. Okay? So parang nandito na tayo. So when we achieve this parang equilibrium condition na to has a parang fixed value, no? So meron siyang based on the delta G calculations, kaya natin ma-determine kung ano yung parang magiging eventual composition or eventual na parang partial pressures. If it's gas, then eventual partial pressures of the different species involved. Tapos kung kunwari aqueous solution naman, eventual final concentrations of the species involved. Okay? So, we don't know what that parang in this parang starting point, no, ito, hindi natin alam kung ilan yung nagta-transform na SO2 to form SO3. Okay? So, hindi natin alam yung change na to. So, we can just say na meron tayong minus X. No? So, okay? Minus X. Now, for every X na babawasan natin sa O2, because of the stoichiometric ratio, meron tayong 1/2 X na ibabawas din sa O2. Okay? And for every mole of etong X reactions na napoproduce, meron ding plus X ng SO3 na napoproduce. Okay? So let's just say meron tayong value dito. No? Kunwari, may 0.5 grams or 0.5 moles of SO2 na nag-react to produce SO3. Then, ang mangyayari is 0.5 dito and 0.25 lang yung nako-consume. And it's because of the stoichiometric ratio. No? Kasi, kumbaga, hindi ka naman pwedeng mag-produce ng kunwari, hindi pwede na 0.5 mag-react dito tapos kunwari 1 yung magre-react ng O2 to produce 0.5 na grams. Always 0.25 lang kasi yan yung stoichiometric ratio nila. So another way of thinking about this is pwede rin actually na hindi ganito, no? So kunwari, let's just say gusto nyo na ito yung X nyo. So you do this as X. Then, ang mangyayari is dapat dito, this should be 2X minus 2X. Kasi for every mole for every half mole ng O2 na nagre-react, meron kang um, 1 mole of SO2. So kung 1 mole yung na nabawas dito, then for every mole dito, dapat may 2 moles na nababawas sa SO2 mo. So you could actually do something like this, no? Minus X. And siguro let's retain this, no? Kasi just to prove na equal yung makukuha yung value either way. You can either do yung minus 1/2 X to, tas dito X, and this is plus X, ito minus X, no? You can do it this way, or you can do it itong this way. So, in your handouts, dun sa yung provided handouts, actually yung minus x tapos minus 1/2 x yung ginamit niya. Okay? So, just to prove na same lang dapat yung makukuha nyo, then let's just use this form right here. Okay? So, ang essential lang dito, class, is you know how much is or dapat kumbaga alam nyo, you understand that merong stoichiometric amounts lang ang magre-react uh, to form a product, um, a product per mole of that reaction. No? So, in fact, may term tayong ginagamit dito. No? So, for example, if you have only 1 mole available for SO2 and you have, kunwari, 100 moles of O2 na available, then actually we call O2 as, sinasabi natin in excess siya. Okay? Tapos, tinatawag natin ito as the limiting reagent. I think you still remember these terms, no? Reagent. So, whenever, kasi again, stoichiometric amounts lang kasi yung magre-react. Okay? So, para siyang, so for example, let's look at the SI, something like, ano ba maganda? Ito, SO2, no? Let's look at SO2. So, for every atom of S, kung SO2 na form, no? And I forgot kung ano yung itsura ng structure nito. Pero let's just say na ganito siya. So, para siyang ganyan. No? Let's just say ganyan yung SO2. No? I'm not quite sure kung ganito nga ba talaga yung form niya. Pero, for example, ito yung sulfur atom. Ito yung dalawang oxygen atoms. Then, para makapag-produce ka ng SO2, kailangan mo ng isang sulfur at dalawang O2. So, hindi naman pwede na, kunwari, 4 na O2 yung mapoproduce mo. Hindi pwedeng ganyan, no? Kasi hindi na yan yung SO2. Tama? So, kaya, kung in excess yung O2 mo, the amount of SO2 na mapoproduce mo is just kumbaga 1 SO2 moles kasi, or 1 SO2 molecule kasi ang limiting reagent mo this time is yung S mo. So kahit sobrang dami pang available na O2 dito. Tama? So now if for example, meron kang isa pang O dyan, then it can produce another SO2 molecule. Tama? So in this case, limiting siya. So kung babalik na rin naman natin, kunwari masyadong marami kang sulfur molecules, no? Tapos konti lang yung um, oxygen, then in excess naman ngayon si sulfur. So it can only produce kung ano lang yung available na limiting reagent. And in this case, pwede siya mag-produce ng isa pang SO2 molecule. No? Pero itong in excess na S, hindi na siya magta-transform into SO2 kasi kulang na yung O2 mo. Okay? So yan yung concept niya. So dapat tandaan nyo lang yung stoichiometric na relationships nila. No? And siguro kailangan nyo din i-brush up on your basic yung college chemistry nyo. No? Baka kailangan yung i-review yon kasi importante ito sa lesson na to. Okay? So again, meron tayong 1 mole for every mole of reaction, 1 mole SO2, 1/2 mole O2, tapos, or sa initial, meron tayong 1 mole SO2, 1/2 mole O2, tapos 0 moles SO3. Tapos when we allow it to react, it should, if you look at the, kunwari, O2 yung tinitang natin, no? So if, for example, there are X amount, X moles na nag-react, dapat merong minus 2x na based on stoichiometry, merong minus 2x na mababawas dito sa 1 mole na to. Okay? Tapos, because nag-react itong 2x na to and x, they should produce, based on the stoichiometric ratio, plus 2x dapat ang mapoproduce mo na SO3. So, with that, so ito na yung ice table natin. No? So, this is your initial. Again, initial. This is the change. And this is equilibrium. Okay? So, yung equilibrium niya is just yung total. So, magiging 1 minus 2x. Ito, 1 half minus x. Tapos ito, 0 plus 2x is just 2x. Okay? So, ito, these are all in equilibrium naman siya. So, parang pwede natin gamitin to as the basis when we compute for K equilibrium. No? So, yung amount kasi ng isang and this when we talk about moles dito, no, pero yung amount kasi ng isang gaseous phase is directly proportional to the partial pressure that it introduces to the system, no. So pwedeng actually pwede natin imagine to as partial pressures na rin. So kunwari nag-start ka with 1 partial pressure, ito 1/2 partial pressure, marireduce yung partial pressure niya by minus 2x amount, ito minus x. Yan. Tapos pagka ano naman, molarity naman pwede ding in terms of ano. Pero usually pagka ganun yung inisip, baka ma-confuse kayo, no. So lalo na pagka kunwari iba yung total number of moles niya, or sorry, iba yung total partial pressure niya, posible mag-iiba yung calculation. No? So it's always just easier to think about it in terms of number of moles. No? Okay? So dito, we can now compute for the total partial pressure. No? If we, wait lang. Okay. So, pwede natin siyang isipin na ito yung magiging at equilibrium, ito na yung final na number of moles, no? Now, if we compute for the partial pressure, yung total kasi na partial pressure, if you multiply the total partial pressure, then actually with the mole fraction, you get the partial pressure. Okay? So, kasi yung mole fraction kasi natin, again, ang sinasabi ko kanina is let's say mole fraction x, no. The mole fraction of a particular na gaseous phase is always directly proportional to the partial pressure it um, it exerts on the system, no. So yung partial pressure, yung mole fraction ng particular species natin will now be equal to just the partial pressure, its partial pressure of the species, no. Let's just call it P sub I, divided by the total na gas pressure. Okay? So in this particular case, hindi sinabi kung at what ano yung total pressure, no. Unlike dito sa taas, sinabi niya na yung total pressure was just 1 atmosphere, no. So it's just kumbaga hindi siya pressurized, wala siya sa isang vessel. And dito, we can assume na nasa isang vessel sila which is containing all of these gases, no. So now, we can compute for P total because at equilibrium, ito naman yung amounts niya, di ba? Tama? Ito, and ito. Okay? So, that being said, yung P total natin will just be equal to 1 minus 2x plus 1/2 minus x plus 2x. That is the total na uh, total total pressure doon sa system natin. Okay? So if you compute that, this becomes 1 plus, ano ba to? Minus x. Ito magiging minus 3x. Ito magka-cancel lang to. Okay? So that gives us x 3 halves minus x. Tama? This is 3 halves minus x. That is our total pressure, no? Now, if you want to compute the pressure, for example, if you want to compute for the partial pressure of PCO2, then the partial pressure of PCO2 is equal to um ay no sorry, what PCO2? Partial pressure of SO2 kunwari. Partial pressure of SO2 is equal to, at equilibrium, it's this value, di ba? So that's, it has 1 minus 2x na moles divided by uh, yung total. Okay? So that's 3 halves minus x. Okay? Tama nga ba? Let me double check. Okay. Tama naman. Okay? So yun. Mamaya gagamitin natin yan. So let's proceed with ano muna, yung computation with the delta G. So dito meron tayong delta G value, no? So we can just take this delta G value right here. Tapos yung delta G value natin is this is at 1000 Kelvin. So that becomes delta G naught is equal to negative 94,600. So hindi ko na i-convert to joules, to kilojoules kasi later on yung R natin naka-joules naman. So that's plus 89.37 joules. 37 joules times 1000 Kelvin. Okay? And this gives us, walang calculator ko, no? That's negative 94600 plus 89.37 multiplied by 1000 Kelvin gives me negative 5230 joules. This is in joules. Okay? So now, pwede ko nang gamitin to produce ito. We already know that delta G from here, no? We know that delta G is equal to negative RTL and KQ if delta G is equal to 0. Meaning it is at equilibrium. So this is equal to delta G negative 5230 is equal to negative RT ln KEQ. So I'm not using reaction quotient kasi I already know na this is in equilibrium. No? So KEQ yung gagamitin natin. Okay, so the negative cancels out. And we can solve for KEQ here. No? So I'll just use my calculator. So KEQ is, again, pwede nyo naman i-solve to manually, no? Pero I just like using the calculator para mas mabilis. Is equal to RT is 8.314 times 1,000 ln times ln KQ, which is x, no? Yun yung hinahanap natin. Okay? Now I do shift solve. And again, I'll just input a positive value, no? Because I know that etong KEQ kasi never siya dapat mag-negative, no? Tama? Kasi if you look at how KEQs are solved, di ba, pagka KEQ, it's always yung activity ng products over activity ng reactants. Tama? And ito, both itong activities na to, hindi naman to, never naman to mag-negative. Dapat Positive siya parati. So, just to be sure that I'm getting the positive root, then I can just input a guess value that is positive. Let's just say 1. Tapos if I solve it, I should get 1.875. 875, and now that is my KEQ. Okay? Okay. So, meron na tayong KEQ of 1.875. Now we can solve for the different partial pressures. No? So, we know that yung, wait lang hindi sinabi yung total. Okay, sige. So, we know that KEQ is equal to 1.875 and that KEQ is also equal to yung partial pressure ng or uh, activity ng SO3 divided by activity ng uh, SO2 tapos activity ng O2 raised to the power of 1/2. Okay? Tapos ito, since these are in the gaseous phases, activities are measured in partial pressure. So that's activity na PSO3, tapos activity ng SO2 is the partial pressure of SO2, tapos ito partial pressure ng O2 raised to the power of 1/2. Okay? So now, how do we use the the itong ano no, itong X values na nakuha natin dito? Okay? So again, sabi natin if you just get the total moles, if you divide the itong moles na number of moles at equilibrium versus the total moles which is ito, we should get the partial pressure, no? Tama? So if I take PSO2, you already solve for PSO2 dito, no? So let's do PSO3 naman. So PSO3 is equal to 2x, ito, 2x divided by 3 halves minus x. And lastly, we have PO2, which is 1/2 minus x over 3 halves minus x. Okay? So if we input all that, and meron ba tayo masisimplify dito? Can we simplify? Mukhang hindi na yata masisimplify. Itong mukhang wala tayong masisimplify. So that's okay. So input na lang natin siya diretso. So we have PSO3 is equal to 2x over 3 halves minus x. Tapos divided by, we have 1, PSO2 is 1 minus 2x over, that's 1 minus 2x over 3 halves minus x. Alright. Tapos ito, we also have 1/2 minus x over 3 halves minus x. And this is raised to the power of 1/2. Okay? So ito, now that we have this, pwede natin i-solve for x, no? Kasi this is one equation which is 1.875 is equal to this equation right here, which is just in terms of one value, no, which is the x value. So hindi natin kailangan ng isa pang equation. We can just directly solve it, and pwede sigurong i-input na natin siya directly sa calculator. You can simplify. You can attempt to simplify this, no? Pwede siguro i-simplify natin further. Ito, magka-cancel out to dito. Tama? That should cancel out. So which leaves us with 2x para lang 1 minus 2x. Para mas simple yung input natin sa calculator. So 1/2 minus x over 3/2 minus x raised to the power of 1/2. Okay, so I'll just use shift solve ulit. So let me set this up. So that's 1.875 is equal to uh, 2x, 2 alpha x divided by 1 minus 2x multiplied by another fraction 1/2 over x. So I'll just do 0.5 para hindi na tayo malito. Minus alpha x. Tapos sa baba, it's 3/2. So that's 1.5 minus alpha x. Now I raise this to the power of 1/2. 1 over 2 or 0.5 na lang diretso. Okay? So I think that's good. So shift solve natin. And again, x should be positive na. So I'll just do a random number. Let's just do 1. And I get x is equal to x is now equal to 0.232. Okay. Now this is 2.232. Ito ay yung x value, no? So we can now compute for yung etong equilibrium conditions natin. So if we substitute x to these values right here, ito is a substitute ko dito. I now have your sorry. Pwede pala i-substitute natin siya dito, no? Para makuha yung partial pressures. Okay? So PSO2 is equal to 1 minus 0.232 over 3/2 minus 0.232. And we should get, let's do calculator. That's 1 minus 0.232 divided by 3/2 minus 0.232 gives me 0.606, which is, bakit iba siya? 232. Okay. Let me solve the other stuff. PO2. Let's do PO2. That's 0.5 minus 0.232. 1.5 minus 0.232. Ano ba ako? Bakit? Ano tong symbol na to? Medyo nalilito ako. Not sure if that means anything. No? 0.2114. Okay. And last is PSO3. It's 2 times 0.232 divided by minus 0.232 gives me 0.36 0.366. Alam ko na. Ito, SO2. SO2 is, bakit to? 1 minus 2x pala. Kaya pala. So, times 2 pa to. Tama kasi ito, 1 minus 2x. Okay. Okay, I think tama na yung sagot. 1 minus 1 minus 2 times 0.232 divided by 3 halves minus 0.232. And you get, it's supposed to be 0.423. Okay. Hello, future Stan here. So I've noticed a few mistakes now. So let me just clarify. So this one, mole fraction is equal to pi over p total, and this is also equal to, I don't know, the mole fraction itself is equal to ni over n total. Okay, so this value right here, where we added all the moles that were present, no? Both reactants, this one, reactants, and the product, which is 2x, is actually just the n total, no? Okay, this is n total. So when we divided the number of moles of the species, for example, this one, 1 minus 2x divided by 3 halves minus x, which is this one right here, this is still just xi, no? So this is xSO2. Okay, so for us to be able to find the pSO2, we need to, if we manipulate this one, no? This becomes p I is equal to the mole fraction x, which is just ni over n total, multiplied by the p total. Okay, so since the p total was not given for this problem, we just assumed it to be just equal to 1 atmosphere, and that's why our final answer, if you look at our final answer, no, we have 0.423, 0.2114, and 0.366. If you added all of this, p total here will be equal to just 1 atmosphere, no, because that is what we assumed, no. Okay, so that's what thus it follows Dalton's law. Okay, so here if we assume that p total is just equal to 1, then the partial pressure of the species is just equal to the mole fraction of that species. That's why we have this one, where pSO2 is equal to 1 minus 2x over 3 halves minus x, which is just xSO2. And that is also similar to the other ones as well, no? So this is like saying that we are just multiplying this. If you want to get the, I don't know, xi, we just multiply it by 1 atmosphere, which is the assumed p total. Okay, so I'll just add a note here. So assumption p total is equal to 1 atmosphere. Okay, so back to the video. So if you look at your handouts, almost the same yung nakuha nating value, no? May konting discrepancies lang. Maybe I rounded off somewhere, or yung sa handouts natin nag-round off siya, no? Pero again, it just proves na hindi nagmamatter kung anong approach yung i-take nyo, no? Whether, basta ang i-take into account nyo lang is always dapat stoichiometric yung change na gagawin nyo. Okay? So, we'll do a bit more problems, pero since at time na, 5:30, for those who stayed, yung nandito, thank you for coming in. No? Shoutout kay Joanna, John, Andre, si Rod, Lawrence, and Mark. Kasi pumasok kayo, no? Pero if you need to go, kasi 5:30 na, you can go. Pero i-continue ko lang yung lesson, no? Just to finish up yung itong different na calculations natin. Okay, so I'll be recording it so you can just view it later on if you have to go, no? And for those listening, hopefully nasusundan nyo naman yung buong ano no, itong buong lecture na to. Okay?
Sir,
Mark,
may
go
tanong
ahead,
lang,
Mark.
marami talaga. Sir, pero ako na sir, paano sir naging 1,000 yung Kelvin yung, temperature natin sir? Di ba
The
900 siya nasundan, 950
gi-
degrees Celsius plus 73. Bakit naging 1,000 po
big
yung kanina?
given naman sabi 1,000 siya. Yung 950 is
Okey,
yung ano, yung sa problem 1.
okey naguluhan ako kaya pala. Sorry sir.
Oo.
Okey, okey,
Ito
okey na.
given naman na 1,000 siya.
Tapos sir, nga pala, mali yung nakopya ko. Sorry, sorry.
Sige,
Tapos
sige.
sir,
Okay lang.
teka lang, saan na ba yun? Nakalimutan ko sir kung ano po nga po yung ano sir, value ng R natin sir.
Yung R
Nakalimutan ko.
8.314. Kung in joules, joules per mole Kelvin, it's 8.314
814. Okay po, joules.
per
Okay.
mole
At saka
Kelvin.
last opo po. Tapos lastly sir, ah, na-gets ko naman po yung sa initial tapos sa change sa teka lang, ito pa pala. Sa initial sir, pero bakit nga po ba sir naging 0 po yung sa ano sir, yung sa products?
Sa initial. Kasi
Opo, opo. Bakit naging
sa start, wala ka pa
kasi
namang products eh. So, ang assumption dito is you have a,
assumption lang
yung,
siya?
kung kumbaga ang sinabi
Ah,
kasi is consider the reaction, no? So, parang ang sinasabi dito is meron tayong, although, yun nga, medyo hindi kasi clear yung question no, kung ano yung nangyari talaga. Pero what this question is asking is meron kang given a number of given products and you allow them given reactants I should say, and you allow them to react to form products. So kaya sa simula zero yung SO3 mo.
bale okey, okey, assumption lang
Mm.
ba.
Pero siguro
Tapos sir
sa problems naman mas explicit namin sasabihin sa inyo no.
okey sige po. Tapos sir, dito sa tawag dito, sa change tama po ba?
Mm.
Ah, na-gets ko naman po yung values na 2 at saka 1 lang sa reactant side. Pero bakit negative sir, negative 2 at saka negative 1x?
Ah, kasi if
Di
you
ko na
started with kunwari 1 mole amount, pagka meron kang nag-react, mababawasan yung initial amount mo by the same amount na ng change na sinulat
reduce siya.
natin. Mm.
So
So
may automatic negative ang sign, tama po ba?
negative siya kasi kumbaga mababawasan eh. Tapos dito
Okey.
naman from 0 madadagdagan siya ng itong 2x so kaya siya positive dito.
Pero bakit siya naging 2 sir? Yun lang din, last question. Bakit naging 2 siya sir,
Kasi
sa
yung
product?
stoichiometric ratio natin is for every 1/2 mole ng O2 gas na nag-react, meron kang 1 mole ng SO2. So kumbaga para siyang ang ratio niya is we have x moles of O2. Therefore, kung i-compute natin yung number of SO2, magiging ganito. 1/2, 1/2 O2 for every 1 SO2. So, this cancels out,
1/2
gives you,
for
oo.
every SO2.
So, nakalimutan ko ng term dito. This is, ano nga yun?
Pero kasi 'di ba
Stoichiometric
'pag titingnan
ratio.
natin 'di ba oxygen ang titingnan natin dito sir, so maintindihan ko sa SO2, 2 talaga siya. Dito naman sa isa sa O2 na sila may 1/2 o times 2, 1. Pero from 3 naging 2, hindi ko gets. Oh my gosh.
Ulit. Kasi di ba, meron tayong X moles. Kung meron kang X moles of O2 na nag-react, yung amount of SO2 na kailangan mong ipag-react to form the products is equal to XO2 multiplied by this stoichiometric ratio right here.
XO2,
Kasi for every
okey.
mole reaction, ganito yung reaction mo eh. 1 mole SO2, 1/2 mole O2. So parang ganito siya. So magka-cancel out yung O2 producing 2x SO2. Okay? So
Okey gets na.
mm,
Without considering sa lumabas na SO3 na product. So hindi
mm,
natin
mm.
titingnan yung nag-base kasi ako dun sa SO3, kaya naguluhan ako. Okey gets na.
Okay. So hindi mo kailangan tingnan
Ah,
yung mga kumbaga
wala na support.
elements. Hindi mo siya. Ang
Tama,
basis natin is yung stoichiometric ratios niya in terms of doon sa balance reaction natin, which is this one.
na balance na reactions lang. Okay, thank you sir. Okay na po.
Okay.
Sagot na.
Sige. So proceed tayo sa other problems pa. Pero again, if you have to go, okay lang. Tapos i-continue ko lang yung recording regardless. No? Okay? So let's proceed with another problem. Ito naman, let's do sample problem number 4. Meron daw tayong molten manganese. Tapos i-compute natin yung meron tayong vapor pressure. Ipapakompute natin yung vapor pressure of manganese in molten steel. Okay? So since this is manganese and steel, then we are talking about fun fact lang, no? Austenitic manganese steel yung tawag natin dito or Hadfield steel. Pero hindi na yun relevant sa problem. Sulat lang natin. No? So let's do to yung problem natin. So the problem goes this way, no? We have we are to calculate the vapor pressure of manganese in molten steel, and this is at 1600 degrees Celsius. And we assume we are given that the manganese evaporates at 2095 degrees Celsius with a latent heat of evaporation equal to 226 kilojoules per mole. Now, if the atmospheric pressure is given as 1 atmosphere, then what will be the resulting na vapor pressure? No? Okay? So, in this case, actually gagamitin natin ay yung Clausius-Clapeyron na equation. No? Okay? So, um, the Clausius-Clapeyron equation is given in your modules. No? So, you just have to look at it. Pero it should be equal to the latent heat of evaporation divided by RT raised to the power of 2 is equal to D LNP over, sorry, that's D LNP over dt. Okay. Now let's try to define some boundaries. No? So we are working at initial temperature natin is T1. That's we started at 1600 degrees Celsius. No? And we should convert na natin agad to sa ano. Kelvin para hindi tayo malito. So that's 1600 plus 273 gives us 1873. Diretso ko na. 1873 Kelvin. Tapos T2 natin is at the evaporating temperature, no? Which is at 2095. So 2095 plus 273 gives us 2368 Kelvin. Right? So, yun yung two temperatures natin. And we will use that kasi mag-i-integrate tayo. No? So, if we rearrange this equation, we can set it such that itong left side will all be in terms of T. So that's RT dt. Tapos dito sa right side is in terms of LNP naman. Okay? So, if we integrate this and our boundary condition is at 1873 or from T1 to T2 which is 1873 to 2368. Okay? Now, we have our P1 and P2 is kumaga yung pressure when it is at 1873. Tapos yung T2 natin is at the evaporating temperature which is given as atmospheric temperature daw. Parang ganyan. Okay, so kaya 1 siya. Okay? So essentially we are actually kumbaga computing for kung ano tong pressure at 1873. Okay? And We call that as the vapor pressure. So let me try to illustrate ito. So kung meron ka kasing um, for example, this is molten steel kasi yung example natin, no? Tapos the manganese is evaporating. Ganyan. Now the vapor pressure is the pressure that this manganese gas is exerting on this on the steel. Now the vapor pressure changes with respect to its temperature, no? So this is like saying na, for example, at 1 atmosphere, um yung at 1 atmosphere na vapor pressure, um 'di ba, gases, or let's take a very simple example, no? At 1 atmosphere, so that is at sea level, no? We can say na yung water natin, or yung water natin boils at 100 degrees Celsius. Okay? So yun yung parang evaporating temperature niya, or boiling temperature. Okay? Now, when you go to a higher elevation where the vapor pressure is smaller, ang mangyayari is actually, and you might probably have noticed this kung mahilig kayo mag-hike, no? At higher elevations, yung yung vapor pressure is actually smaller, and that's why parang mas konti yung, or mas mababa yung magiging boiling temperature ng water natin. Okay? So that is what is happening here, no? Parang ang ginagawa natin is at hinahanap natin kung kumbaga at another temperature, at a different temperature, um nagbabago yung magiging parang vapor pressure na in-exert ng manganese gas natin towards the system below it. Okay? So kaya hinahanap natin itong P at 1873. Okay? Which if you could predict this should be at a lower value. No? Okay? Tama ba? Wait lang. Let me think about it. No? Dapat ba mas mababa siya? Hmm, tama, no? It makes sense. Dapat mas mababa kasi normally, parang pwede natin isipin na ganito siya, no? Normally, if normal conditions siya, dapat ang kumbaga melting temperature, or sorry, ang boiling temperature niya, or yung evaporating temperature should be at 2368. Pero since mas mababa yung observed niya na kung kumbaga hinahanap natin kung ano yung vapor pressure kung pinapa-evaporate natin yung molten steel at 1873. So it makes sense na dapat ito mas mababa dapat tong vapor pressure na to. So this is similar to yung simplified example ko ng water, no? So kunwari yung water evaporates at 100 degrees Celsius if normal conditions, pero once nasa higher elevation ka, like in the mountains, which has lower vapor pressure, we expect na mas mababa yung magiging niya, yung boiling temperature. Ang difference lang dito sa example na to versus doon sa water example is that ang given naman is yung temperature, tapos pinapahanap sa atin kung ano yung vapor pressure. Okay? Okay? So parang ganyan natin siya iisipin. So it makes sense na dapat expected, if we did our calculations correctly, dapat ang expected na sagot dito should be lower than 1. Okay? And kung mas mataas to, kunwari ang pinapasolve is something like 25 Kelvin, then we could expect na dapat itong vapor pressure na to at this 2,500 Kelvin should be greater, no? Okay, so let's try to solve this. We have LE is given as sabi daw 226 kilojoules. So i-convert na natin kasi R natin is in joules. No? So that's 8.314. Tapos, this is T squared and we are evaluating from 1873 to 2368. Okay, you can actually evaluate this, no? Pero ako i-retain ko na lang kasi gagamitin ko naman yung calculator. Tapos para less yung kumbaga computation na kailangan gawin ng calculator kasi the more complicated the equations are, the more likely na parang hindi gagana yung calculator nyo, no? Unless of course you have a more advanced calculator. Pero usually dito sa pagka masyadong madami yung um, kumbaga kung masyadong komplikado yung equation, hindi niya nako-compute properly. So I'll just evaluate yung mga simple. Kunwari itong side na to, it can be evaluated easily, no? So D, L, and P, wala namang anything inside. So this just becomes L and P. Evaluated at that's from 1873 to evaluated at the vapor pressure at 1873 papunta sa 1. So if we further evaluate this just becomes ln 1 over P1873. Tama? Kasi ito, pag nag-evaluate tayo ng ganito, magiging ln 1 lang siya minus ln P1873, which is, if simplified, magiging ganito lang din. Okay? So, let's try to evaluate this. And hopefully, kaya ng calculator natin. No? If not, then kailangan natin i-evaluate tong left-hand side. So, if we do this one, inside natin is, let's do a fraction. So, 2 to 600 divided by 8.314. 8.314 and multiplied by alpha x squared. Tapos ang limits natin is from 2, this is 2368. Tapos from up, ito, 1873. Okay? Tapos i-equate natin siya sa mahirap pala kasi i-evaluate na lang natin muna to. No? So if we do equals, so that's 0.303, let's just say 3034 is equal to ln 1 over P1873. Okay, so if ano natin to, alpha equals ln ng 1 over x, and let's do shift solve. And we also note na dapat partial pressure nito is a positive number. So let's just input a positive guess value. So we get P 1873 is equal to that's 0.74 or 738. See, 738 na lang. 738 atmospheres. So this is the vapor pressure so this is the lower vapor pressure, no? Which resulted in which resulted in the evaporation temperature lowering into 1873. Okay? So parang yun yung sinasabi sa problem na to. Alright? So nakuha ba yun? This is a little bit simpler yung parang equations na ginagamit, no? So we already have this equation. Again, this is the Clapeyron equation. Tapos siguro ang interpretation na lang kung paano yung parang state 1 to state 2 niya, no? yung evaluation niya. Okay? So, mukhang may mali ata sa module, no? Mm, let me double check. 0.3. Kasi hindi ko nagkamali lang to. 3.033 kasi dapat 0.3033. Pero anyway, I'll double check that. Pero this makes a lot of sense, no? Kasi um, magkalapit lang naman siya, yung 2.3 and 1.8. So it makes sense na magkalapit lang din dapat si 1 atmosphere and itong 0.7384. Pero I'll double check just in case, no? Pero and maybe some of you have ano no computed this along with me. Same ba tayo ng na compute 0.3 especially dito sa left hand side. No? Let's do that again. 2,600. Mukhang mali pala ako. 6,000 pala dapat. Let's do it again. For alpha x squared. This is from 1873 to 2368. Ay, okay. Tama pala. Okay, I'm sorry. So it's not 0.303. It's 3.003. Tama ba? 226 kilojoules. So that's 3 zeros dapat. 22600. So 226,000 over 8.314 x squared 1 is 73. Tama. So, sorry. Mali to class, no? So if we evaluate this, so let's just do alpha equals ln ng 1 over x, alpha x, shift solve, and this is a positive, so okay lang. 0.048 dapat. Okay, so tama pala yung nasa modules natin. So does it make sense na sobrang mas mababa siya? Sa bagay, sobrang layo naman pala nito. It's 1873 plus 2368. So that's a difference of almost 500 degrees Celsius. No? Tama? 500 degrees. That's quite a lot pala. Uh, I'm sorry. Hindi pala siya maliit lang. No? 500 degrees is a lot. So siguro yung mga maliliit lang is from 100 magiging kunwari vapor temperature ng water is 100 tapos you observe na at the mountains naging something like 96 siya. That's a small amount. So expected na point something lang. Pero with this case, sobrang laki pala ng difference. So it makes a lot of sense na ganito kaliit yung vapor pressure niya. Okay? So nasundan pa to? Problem 4. Okay pa tayo dito? And actually, last problem na tayo. So if you're still game about it, no? Yung mga nandito. So pasensya na, medyo mahaba yung extension natin. Pero thank you for staying along. No? So I'll proceed. Pero kung baka may tanong kayo, Andre, Lawrence, or Mark, wala naman.
Ay, sir, wait lang po. Sir, last ko lang tanong, sir. Tanong ko lang po
Sige, go
kung ano
ahead.
pangalan po sabihin ng LE. Yun lang yung
Ano yun?
tanong ko,
Sorry?
sir. LE.
Yung LE. L
Opo,
sub
ano lang.
E is the latent heat of evaporation.
Ayun lang yun. Okay, sir. Thank you po. Okay na po.
Okay. Okay, so we proceed with our last no. Okay. So ito, meron daw tayong gas mixture of 50% and this is probably a hard problem no kasi meron siyang different na mix. Basta usually pag gas mixture problems, medyo mahirap no kasi we have to take into account the percentage of each of the gases. Okay, so we started with a gas mixture of 50% carbon monoxide, 25% carbon dioxide, 25% H2, and this is by volume. And we feed it into a furnace at 900 degrees Celsius. Now, we want to find the equilibrium composition of the exit gas if the total pressure in the furnace is equal to 1 atmosphere. So the reaction is as follows now. Okay, so the thing we do with these types of problem is that this is actually a ice stable type of problem as well. No? Because if you look at it, you have an initial value which is yung mga 50%, 25, 25. Tapos meron kang change which is when the reaction proceeds. So yung dito, when the sorry. Dito sa part na to, this is where your reaction proceeds. No? So meron kang change. Kumbaga, yung 50, 25, and 25, pwede magbago yung, kumbaga, if you remember the drawing na ganyan. So you might have started here or hindi natin alam. No? So it could have been this side, right side, or nasa left side siya, whether product favored or pero we can, ano pala. So it's 25% products, 25% H2, tapos 50% CO. So therefore, 50, it's 100. Wait, sorry. Tas zero. So zero tong H2O natin. Okay, so in that case, mas madaming, hindi rin masabi natin pala. So anyway, hindi naman nagmamatter. Pero ang sinasabi ko is, we started it off with something like this and it wants to find the equilibrium. So after it has reached equilibrium, mag-exit na siya doon sa gas natin. No? So parang ang nangyari is, you feed your gas. So kunwari ito yung inlet. So this is the gas mixture. Pasok mo dyan. So that's your initial. Papasok siya dito, you are allowing it to react at a particular temperature, that's 900 degrees Celsius, that's your change. Tapos, lalabas siya as flue gas or exit gas. So, exit siya and that is now at equilibrium na siya dito. Parang gano'n. Okay? So, or pwede rin isipin nyo na nag-equilibrium siya dito pero to simplify, para siyang ganito. So, it makes, the gas mixture goes in, it proceeds with the reaction. So that's your change. Tapos, after reaching equilibrium, pwede siya mag-exit to the atmosphere. So, we need to do an ice table ulit. No? Okay? So, let's set up the ice table dito. Okay, so erase ko muna to. Or sige, i-retain ko na lang to para may visual cues kayo. Okay? So, you started with, so the reaction is CO2 plus H2 yields CO and H2O. So hindi ko na isusulat yung gases, no? Kasi I know that all of these are gases, no? So ibig sabihin pag nag-compute ako ng reaction quotient or equilibrium constant, always kumbaga ano ako, partial pressures. Okay? So set up my ice table. Ice. So initial is I have 50% CO. So kung yung again pag gases class, I think this was discussed before sa ano, no. Sa chemistry sa college chem diniscuss to, pero I think doon sa ano din gas laws diniscuss din to, no. Yung amount ng material or amount yung tawag dito, yung concentration ng isang gas equal din siya sa parang partial pressure na in-exert niya, which is also equal doon sa available volume niya. Because di ba pagka mas malaki yung volume ng isang gas, mas malaki yung partial pressure na ine-exert niya. Okay? So that's why kung sinabing 50% siya by volume, then that's also saying na its partial pressure is 0.5 and therefore its molar fraction is also 0.5. Okay? So you begin with 0.5 yung ano mo, yung initial. Then etong CH2 is also is 0.25, sabi dito. It's 25%. So nandyan, no? 25H2. Tapos CO is you have a mixture of yung gas mixture mo, no? 0.25 din. Tapos si H2O, wala kang initial H2O which means na zero yung initial niya. Okay? So once pumasok siya, then the reaction proceeds. So may change ka. Then we just use X. No? So let's just say minus X to, no? So minus X, kung minus X to, then this is also minus X. And luckily, 1 is to 1 is to 1 is to 1 lang sila lahat. No? So mas madali siya. So plus X lang siya. Tama? So now we have 0.25 minus X. This is 25, sorry, this is 0.5 minus X. This is 0.25 minus X. Ito naman 0.25 plus X. Tapos ito is 0 plus X, which is just X. Okay? So, with that, meron na tayong, kumbaga, equilibrium conditions or equilibrium na molar concentrations, which is the partial pressures. No? Okay? So, we can solve for this, no, using our delta G. So let's start with delta G muna. So nandito naman ang delta G. Tapos given yung mga different half reactions natin. So let me just move this part. Adjust ko lang. Sorry. Move ko lang siya. Pwede. Okay lang pala yan. Ito, galawin natin. Okay. So ito, compute natin yung delta G. No? So the delta G as a function of temperature for every stepwise reaction is given. No? So we need to kumbaga tingnan natin siya kung mayroon ba tayong kailangan i-reverse. No? So obviously this needs to be reversed kasi CO2 is in the reactant side. So this gives us, this is CO2.
Okay. Sir, may tanong lang po ako, sir. Pasensya na po, ah.
Sige,
Sir,
go.
naguguluhan po. Yung sa initial, sir, bakit po nag-interchange yung ano, sir, values ng percentage ng CO2, ng carbon dioxide at saka ano, carbon monoxide? Hindi ba, sir, ano siya?
Nag-interchange ba siya? Sorry. Salamat, Mark. Dapat 0.25 to. 0.5.
Ano ba?
Sorry na-confuse ako, no?
Sige po,
Tama,
salamat.
carbon monoxide nga yung ano. So dapat baliktad. Thank you, Mark. Ito plus X, tas ito 0.25 minus X. Okay? So ito, so let's solve for ito muna, no? So tingnan natin yung equation. So that's CO2 yields C plus O2. Tapos, therefore, yung delta G nito is baliktad nito, no? So that becomes negative. So that's magiging positive 94200 minus 0.2T siya. Okay? Tapos yung next natin is CO. So it's on the product side. So tama na to. So I think no adjustment is needed dito, no? So gives us CO gas, which is given us negative 26,700 minus 20.95 T. Ito all in calories naman to. So iba yung gagamitin natin ano, no? Gas constant. Okay, so ito last is H2 product side, which I think i-retain natin siya sa product side as well, no? By the way, balance reaction nga ba to? So we have C1, C1, C3, 2, O, dalawang O, dalawang H2. So balance naman siya. So no need to balance it. Ito 1/2 O2 yields H2O. And pwede natin copy lang siya. So isa lang yung binaliktad natin, no? Which is yung first equation. And just to check natin kung magka-cancel out nga ba to. So this one cancels out. Tapos, wait. This cancels out 'to, yung 1/2 O2 ito. Tama? Kasi dalawang 1/2 O2 tas 1 O2 dito. That cancels out gives us yung CO2 plus H2 yields CO plus H2O, which is our balance reaction right here. Okay? So, okay tayo. So, kailangan lang natin siyang compute dito, no? So, ano ko lang to. Okay? So, ito, compute natin. So, that's calculator ulit. Calculator. So, that's 9. That's positive na 9 for 200 minus 26,700 minus 58,900 gives us 8,600 plus sorry, hindi pala natin sure kung plus nga ba. So that's negative 0.2. Sorry, plus na dapat to, no? Kasi mag-negative siya. So that's plus 0.2 minus 20.95 plus 13.1. Okay, gives us negative 7.65 T. Now we can compute for delta G naught, delta G. Delta G naught pala to. And it's, ano ba to? Delta G naught at what temperature? 900 degrees Celsius. So that's, multiply lang natin diretso. 900 plus 273, which is 1173, no? Gives us 89 plus 86. 8,600. So that's negative 373.45. Joules na to, no? Sorry, cal. Cal pala tayo. So this is supposed to be in cal. So just double check class, no? Baka mali yung in-input ko, pero I think okay naman. Tapos ay may mali sa ano kasi inassume niyang joule siya pero cal dapat siya. So okay lang. So we'll have to check, no? So delta G naught is negative 373.45 calories. So we need to get the gas constant in terms of in terms of calories. So pag calories siya, it's, let me take my search lang natin saglit last na. Pag calories, it's 1.98 times 10 to the negative 6. Tama ba? Tama nga ba? In cal. 1.98. Tama. 1.987. Okay. So, if we compute for delta G naught, sorry. So, pwede diretso na natin, no? KQ is equal to, or ln KQ is equal to negative delta G divided by RT. Tama? And RT is equal to 1.987 kasi calories to. 1.897 multiplied by, we are working at 1173. Okay. So compute KEQ should be e raised to the power of ito. No? So let's compute. KEQ gives us, diretso ko na class, no? We have shift E. Tapos, yan. Positive na. So 373.45 divided by 1.987 multiplied by 1173. Okay. So gives us KQ of 1.173. Okay. So we have KEQ. Now we can equate this to partial pressures. No? And since all gases naman to, so we have, and nakaano naman sila, if you look at the equation, no? Stoichiometric ratio nila is 1 lang. So all 1 mole. So pwedeng lagay lang natin diretso P H2O PCO over PCO2 and PH2. Okay? Tapos, itong mga partial pressures na to can be found by just taking the total. So we know the total, P total is equal to 0.25 minus X times 2 ko na. Sige. Ano ka lang. Minus X plus 0.5 plus X plus X. Okay, so that gives us, magka-cancel ba? Mukhang magka-cancel, no? Wait, does it make sense? No, magka-cancel. Okay lang. So this cancels out. And 0.25 plus 0.25 plus 0.5 is equal to 1. So 1 atmosphere yung total. And therefore, yung partial pressures nila will just be equal to PCO2 is equal to 0.25 minus X over 1. Tapos PH2 is 0.25 minus X lang din. PCO is equal to 0.5 plus X. And what's this? PH2O, last natin, is equal to just X, no? And we can input it here. PH2O, that's, so PH2O X times PCO, which is 0.5 plus X over PCO2, which is, oh, sorry, 0.25 minus X. And same lang sila na sa H2, no? So we can just do squared. Okay. And if we solve it, this is equal to 1.173. Let's use our calculator again. 1.173 is equal to X multiplied by 0.5 plus X divided by 0.25 minus alpha X, and that's raised to the power of 2. Shift solve, and positive ang X, okay lang yan. So we get X is equal to 0.068. X is equal to 0.068. So input that 0.068 here, and you should get the final answer. Sige, try natin input siya. Save natin ito. Paano nga ba ito? forgot how to use memory. Oh, di ako marunong gumamit nun. Sige, anyway, okay lang. So, 0.25 minus 0.068 gives me 0.182. So, pH2O is also 0.182. And CO is 0.5 plus 0.068, 0.5568. And last is ito, 0.068. And dapat mag-equal to kasi these are percentages, no? 18.2%, 18.2, and this is 56.8%. This is 6.8%. Dapat kapag pinag-add natin to, they should equal 100%, no? 18.2 times 2 plus 6.8 plus 6.8 gives us 100%. So it makes sense, no? So ito yung magiging final composition ni flue gas, no? This one right here. All right, future stand here again. So this is not P total, no? This is supposed to be N total. So this is supposed to be N total. And the N total is equal to 1, I'm sorry, 1 mole. So this is supposed to be 1 moles. Okay, so that's why your X molar fraction, X is equal to Ni over N total. And since N total is just equal to 1, so whatever we have here will be the molar fraction. Now, similar to what we did earlier, P atmosphere is equal to 1. And for this problem, we don't need to assume because it is actually given, no? That the total pressure inside the furnace is 1 atmosphere. So in this case, since we have P total equals 1 atmosphere, so let me just place it here. P total equals 1 atmosphere. Therefore, similar to what we did earlier, our partial pressure will just be equal to Xi, since we're just multiplying this by 1 atmosphere. So if we look here, this is over 1 mole. Let me just add it here so that we are, and again 1 mole is taken from here. Now if we add this all up, the X cancels, and we give it leaving us with just 1 mole. So that's 1 mole, and 1 mole right here, and we are multiplying it by 1 atmosphere to get the partial pressure. Okay, which doesn't really change our final answer, no? 1 atmosphere, but just to be accurate, I'll just add this, and if you do that, we get these partial pressures right here, which translates to volumes as well, no? Because again, our partial pressures Pi is also equal to the volume that it occupies, no? Okay, so therefore, if we have or rather to be more accurate, no, the partial pressure divided by the total is also equal to the volume that it occupies over the total volume. Alright, I hope that makes sense. And let's get back to the video. Okay, so fairly similar lang siya doon sa ano, no, yung naunang calculations natin. Wala masyadong pinagbago. Okay, so that's our last problem for today.
Sir,
Questions?
may tanong ako. Wait lang,
Sige,
sir, pasensya na po talaga. Sir, di ba po
okay
sabi
lang.
niyo po yung rule regarding po dun sa yung sa activity sa KEQ, di ba
Mm.
po pagka pure element siya, mag-e-equate siya to 1? Paano po
Mm,
yung sa
mm.
hydrogen, sir? Hindi ba siya
Kasi
nag-equate?
si hydrogen, naka-diatomic na form kasi ito, yung H2. Pure
Okay.
element is if naka-H lang siya.
Okay, 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 okay.
So
Get
H2 naman siya, so hindi siya yung pure elemental form niya.
okay. Sige po. Tapos last sir, sir di ko talaga ma-get sir, bakit sa change sir, ano sir sa moles, bakit naging negative x na lang siya? Bale bakit 1 na lang yung value niya?
1 na
Bakit?
lang. Ulit,
O sa C
bakit?
po?
Sa total
Sa change
or sa C?
sa mole sa change sa C.
Sa C
Bakit
kasi
naging negative?
'di ba tig 1 mole, sorry, tig 1 mole lang naman sila, 'di ba? So kung may 1
Pero
mole ka ng sige, sige, go.
pero nagulat mo bakit po sa number 2 na sample sir, bakit, parang ang binase natin sir is yung parang ano, molecular atoms ba tawag diyan, ng ano po, ng oxygen?
Ay hindi siya based
Ni
on oxygen, based on stoichiometric ratio 'to. Kasi kunwari ito, let's take this for example, no? So
sa number
if we
2
sa number 2,
po. Kasi kunyari kung ma-gets ko siya kung sinasabi niyo pong sa if based upon sa coefficients, 1, 1 pero bakit sa number 2 po sir gano'n? May for, SO2 that is -2 and then for the oxygen na may coefficient na 1/2 is 1 lang, parang gano'n. Sa reactant side po ako naguguluhan.
sa reactant site, ah,
Opo,
hindi ko gets yung ano mo question. Ulit,
ito po
bakit?
kasi na-gets ko na po yung ibig sabihin niyo sa number 3 pero sa number 2 naguluhan ako kung ano ba talagang tamang ano, pag-analyze diyan sa change ng moles. Bakit po sir, na -2x at saka -1x na lang?
Kasi, we started with etong x 'no, parang nag-assume tayo na minus x siya. And again, hindi
Opo,
nagma-matter kung ano 'no, kasi 'di ba sinabi ko kanina na do'n sa ano nga, sa modules natin do'n sa sample handouts natin, ang ginamit nga niya is x dito is 1/2 x, and dito is plus x.
saan po yung
Do'n sa
iba?
handouts, ganito yung ginamit and ito yung una kong pinakita 'no, tapos sinabi ko na it doesn't matter and kaya natin i-prove na kahit ito yung form na ginamit natin, magme-make sense pa rin siya. In fact, puwede kong baguhin 'no. So if I tried to do, for example lang, if I did na for example, sabi ko, ang nako-consume dito is -3y. Doesn't really matter, puwede yun. Puwede mong gawin yun kasi change lang naman
Okay
'to,
gets
this is a
na.
variable. So for
Okay,
every
gulay.
3y na kakainin dito, magiging -6y 'to. Tapos ito
Nilagyan mo na lang tinimes mo na lang
6y.
2. May gulat naman ako. Okay, sige po
So
gets na.
kumbaga, yung change
Kinabahan
kasi
ako.
is, ano lang, kumbaga, it's up
Variables
to
na po
you
siya
kung
nilagay.
paano mo i-set up yung variables mo. So that
Ay
just
naku,
proves na ano siya. So puwede nga
variable.
dito ang ginawa mo is -2x, hindi rin nagma-matter yun. So -2x ka diyan, -2x, +2x, +2x. As long as
Ay,
yung every change na ginawa mo is stoichiometric siya for every
okay, okay.
mole of the reaction.
Salamat sir. Thank you, thank you.
Okay.
Okay na po.
And, siguro we're running late 'no, pero meron pa tayong, isa pang problem actually. Pero again, if you have to go, okey lang, it's perfectly okay 'no. Ito, tatapusin ko lang for those na makikinig sa, video lecture na 'to, okay. So problem 6, may problem 6 pa pala tayo, hindi ko napansin. Okay, so that's, problem 6. Meron daw tayong reaction and this is SO2 and SO3 naman. Although let me double check 'no kung itong problem na 'to is similar. If it's similar, puwede ko nang hindi gawin 'no. Think wait lang. Mukhang wala palang problem number 6 na hindi na natin sinolve. So, mukhang okey na tayo. I think this is, all for today. So thank you, for listening. Tapos siguro I'll just meet you after the exam na 'no, kasi exam na pala next week. Okay,
Sir,
unless of course may questions pa?
sir, wala akong question sir. Puwede po
Hmm,
magpaiwan sir. May may sasabihin lang ako.
sige, okey lang.
Mm.
Lawrence, mukhang okay na tayo. So I'll stop the recording na 'no. I think, we can end the session right now.